Okay, Waka, today we're going to activity 4.4 using algebra to write quadratic equation. In the previous activity, there were times when you could not determine a quadratic equation using known strategies. You know how to use it to determine the equation, but what if you don't have technology? All right, you know that you need a minimum of 3 nonlinear points to create a unique parabola. To create an equation to represent the parabola, you can use a system of equations. Now, I'm going to let you read the worked example. You're welcome to use this method if you'd like. Okay. Again, you're welcome to read through that and use that if you'd like. But I'm going to show you how to work question number 1 using, I think, a method that's a little bit more efficient. Okay. They're both mathematically correct, and I'm going to show you one. You could use the method in the book or my method. Feel free to decide. Now, what we need is standard form. So f of x equals ax squared plus bx plus c. Okay. Now, we're going to plug where this is x, f of x. Okay, x, f of x. Okay, and then same thing, x, f of x, x, f of x. Okay. So we're going to have 3 equations. So we're going to plug this point into here, this point into here, this point into here. And I'm going to, this is correct, but I'm actually going to write it like this. And you'll understand why when we start using the matrices, okay? All right, so we plug these in. So that's a parentheses -1 squared plus b times -1 plus 1c equals f of x is 5. Okay, now let's plug this point in. So that's a 0 squared plus b times 0 plus 1c equals 3. And then that's a times 3 squared plus b times 3 plus 1c equals 9. Okay, so now this we can go from here to the matrix. Okay, so then that becomes 1, 0, 9, -1, 0, 3, 1, 1, 1 times a, b, c equals 5, 3, 9. And then to solve this, we remember that x equals a inverse b. To find out what a equals, what b equals, and what c equals. Okay, so let's go to Desmos. Matrix calculator. New matrix is a 3 by 3. So 1, -1, 1. And we can make that row, that column 1. So that's always going to be 1. So 0, 0, 1, 9, 3, 1. Press enter. New matrix, it's a 3 by 1. That's 5, 3, and 9. Press enter. And then we're going to do A inverse B. So A equals 1, B equals -1, and C equals 3. Okay, so our equation is f of x equals 1x squared minus 1x plus 3. All right, go ahead and finish that up. All right, let's take a look at the next page. All right, we're going to skip page 163, or omit it. You're going to omit number 2, question 2. All right, talk to talk. Fantastic feats of function. The Amazing Larry is a human cannonball. He would like to reach a maximum height of 30 feet during his next launch. Based on Amazing Larry's previous launches, his assistant Dejan has estimated that this will occur when Larry is 40 feet from the cannon. When Amazing Larry is shot from the cannon, he is 10 feet above the ground. Write a quadratic equation to represent Amazing Larry's height in terms of distance. So let's let h of d represent Larry's height in terms of distance, d. And let's use the equation h of d equals a parentheses d minus h squared plus k, where h is 40, k is 30, d is 0, and h of 0 is 10. Okay? And we're going to plug these numbers into here, solve for a. So that's 10 equals a parentheses d is 0 minus h is 40 squared plus 30. Okay, so we know we have 10 equals, let's find out what. So we need to go to Desmos, Math Tools, Scientific Calculator, parentheses 0 minus 40 squared is 1600. So that's 1600a plus 30. Subtract 30 from both sides. You get -20 equals 1600a. Divide both sides by 1600. So a equals, so let's do -20 divided by 1600 is negative 0.0125, which is also equivalent to -1 divided by 80 equals a. You can use the decimal fraction. I'm just going to use a fraction. So the equation for Larry's is, and I guess I can write it here, h of d equals, all right, h of d equals -1 divided by 80, parentheses d minus 40 squared plus 30. All right, so go and finish up number 1. All right, let's take a look at number 2. Crazy Cornelius is a fire jumper. He is attempting to run and jump through a ring of fire. He runs for 10 feet. Then he begins his jump just 4 feet from the fire and lands on the other side 3 feet from the fire ring. When Cornelius was 1 foot from the fire ring at the beginning of his jump, he was 3.5 feet in the air. Okay, so let h of d represent Cornelius' height in terms of distance d. h of d equals a parentheses d minus r1 parentheses d minus r2, where r1 is 10, r2 is 17, d is 13, h of 13 is 3.5. Okay, so we're going to plug these numbers in, solve for a, and now we have our equation. So 3.5 equals a parentheses d is 13 minus 10 parentheses 13 minus 17. Okay. So let's go ahead and put that in our calculator. So parentheses 13 minus 10, parentheses 13 minus 17, and that's negative 12. Okay. So 3.5 equals negative 12a. Divide both sides by negative 12. So a equals 3.5 divided by negative 12 is, let's just round that to one decimal place. So negative 0.3. Okay, now we have a, we can write our equation. So h of d equals negative 0.3 parentheses d minus 10 times d minus 17. All right, go ahead and finish up number 2. All right, let's take a look at it. Harskanars is attempting to jump across an alligator-filled swamp. She takes off from a ramp 30 feet high with a speed of 95 feet per second. Write a quadratic equation to represent Harskanars' height in terms of time. Let h of t represent Harsh's height in terms of time t, where h of t equals negative 16 t squared plus v naught t plus h naught, where v naught is the initial velocity, which is 95, and h of naught equals the initial height. So all you do is plug these numbers into the equation. So h of t equals negative 16 t squared plus 95t plus 30. So finish up 3, omit 4, okay, and let's take a look at the next page. All right, student works 1, 1, 3, and 4 on page, oh, here, I'll go slow. Page 175. Okay. You can basically cut out this page. And if you would, go and start working on your assignment and have a wonderful Wildcat day.